A decade ago, sequencing a human genome was expensive, and the cost has really reduced over the last 10 years. And as you guys know, with LLM, generative AI, foundational models, AI has been democratized. So it's really easy to models. However, there is a chasm between those two where it's really hard to do data engineering and build your data infrastructure, even still. And it's really hard. How do you limit the noise to signal ratio from your data? So I feel like 10 years ago, the opportunity was more data management. But now the opportunity for biotech companies, especially AI enabled biotech companies, is to really have their infrastructure ready so they can become truly AI enabled. What that means is, let's take an example. Let's say I'm using generative AI and I'm putting in all my Zoom recordings into generative AI to figure out what my actions are. Now, I could put all of my Zoom recordings for last 5 years, but then the noise to signal ratio would be really high. It would not give me really good insights from those recordings. So we still need some sort of data engineering or figuring out how can I build a data infrastructure to make this data AI ready. And I feel like this really translates into biotech as well, where we can build AI models really well. It's almost democratized with LLM and generative AI. We can also capture or generate a lot of data, but it's really hard to build a data infrastructure that connects those two dots. And that was the theme, and that's what we heard from a lot of folks in the industry. And we thought it'd be good to bring in a couple of speakers who have done this really well and talk about how they're building AI enabled biotech companies. Let's get to the next slide. So what I'll do is, in terms of data infrastructure, I have a shameless plug of Scispot, but I'll talk about why data infrastructure matters to me personally, and where AI enabled biotech companies can leverage some of the data infrastructure that is already available to make AI enabled companies. Before I talk through this slide, I come from a travel tech world where data engineering is probably 10 years ahead of biotech, which is a shame because biotech has the most expensive data and there's more meaningful things that you can do within this industry. But I think things are changing. There's a lot of computational people in AI companies such as Protake and Persist AI who are really changing the landscape where they're building the company from data, from AI first. But how do you do that? You do that by essentially building a foundation where you can engineer your data, make it AI ready, but also automate some of the pieces in that workflow. So some of the things that we've noticed with Scispot Lakehouse for our customers is bringing disparate data sources in one spot, but also rationalizing that data and making it interoperable. So let's say if you have disparate data endpoints, the most time that R&D folks kind of spend is the DevOps, the maintenance. If the API changes or if the schema changes, how do you maintain a consistent structure or a consistent schema? How do you build data governance or data schema that can be used across your pipeline? So some of those things can be rationalized and assessed within what we call a lakehouse. And that's been our focus as we build Scispot as well. And in the industry, we are seeing more and more vertical software as a service coming in now. And I think we need more entrepreneurs to come in, both from the tech world and the bio world, to basically build the next gen data lake and lakehouse in the industry. What are the outcomes? Why do I care? So what? And I think one of the things that really matter in this industry is establishing data integrity. It's really hard to build a data dictionary from scratch. So let's say if you're starting a proteomics company and you have a data dictionary in mind, it's really hard to maintain that as you evolve from a startup to scale up and as you go further beyond that. And that's where data infrastructure with orchestration engine comes in play, where you can create your knowledge graphs even right from the beginning. You can manage your metadata as you're building that data infrastructure. The other key aspect that I've noticed, which is really important, is making sure that whatever you do, however you store your data in your infrastructure, you can make it ready for machine learning. So if you do have downstream pipelines, which ComBio folks are using, your R&D data is ready to be analyzed or ready to be fed into some of these pipelines. This should be simple, right? But in a lot of cases, I've noticed people keep updating their schemas, their APIs, and do a lot of DevOps work to make that data ML ready.